Welcome all to Newton's laws of motion class 3, and which we'll discuss about impulse. Let's see in general when we'll calculate the value of impulse. So assume that there is a ball of mass m which is moving towards a wall which is at rest or fixed over here, and it is moving with the velocity u, and it make a collision with the wall. And after collision, assume that this is moving in the opposite direction with the velocity, let's say, represented by v over here. So in such a situation, like in case of during collision, sometimes it may be difficult to find out the value of force exerted by the wall on the object, because for the calculation of force we should know the value of change in momentum that we can find out from the initial and final momentum, but we don't know what about the value of time taken for its collision, or time during which this object is in contact with the wall. So in such a situation, if you don't know the value of time, then it's difficult to find out the value of force. So in such a situation, instead of finding out the value of force, we'll find out what about the product of force into time, which is nothing but change in momentum, which is known as nothing but impulse. So over here I'm just representing impulse by I, or sometimes we'll use a symbol J for impulse. So just remember that impulse is nothing but the change in momentum, or we can write it as a product of force into time. Now I will discuss what are the different situations in which we'll calculate the value of this impulse. So in the first situation, assume that the force acting on the particle is equal to a constant, or if a constant force is acting, then how we'll calculate the value of impulse. So you can write force is equal to a rate of change of momentum, or change in momentum divided by time. So you can write the value of this force into time will be equal to the value of change in momentum, that we can find out from the value of initial momentum and final momentum, or final momentum minus initial momentum is going to give the value of change in momentum. Now we'll consider a situation in which the force is not a constant, force is varying as a function of time. So let's say if force is not equal to a constant, then how we'll calculate the value of this impulse? Then we can go for that instantaneous change in momentum, that is force is equal to dp divided by dt, and you can write the value of f into dt will give the value of instantaneous change in momentum. Now if you want to find out the value of total change in momentum, as instantaneous change in momentum is f into dt, so we can write for the total change in momentum, we can go for integration of f dt within the specified limit of time from take it as t initial to t final. So integration of dp will give the value of delta p, or change in momentum, that will give the value of impulse, which is equal to integration of f dt with the proper limit. Now just remember that if there is a graph which is shown between this force which is varying as a function of time, if ft graph is given, so already we know that area under the graph drawn between y and x axis will give the value of integration of y dx. Over here this area under force time graph will give the value of integration of f dt, and the integration of f dt is the value of impulse. So just remember that area under force time graph can also give the value of impulse, and impulse is a vector quantity, and remember that the direction of impulse is along the direction of change in momentum, not along the direction of momentum, and change in momentum is always, we'll write final momentum vector minus initial momentum vector, or it is the product of force into time. Hope so that you understood whatever the things we discussed in this class. If you are having any doubt, please contact. Thank you.